Good day, welcome to my office. I'm Dr. T. When it comes to actually doing science, it's helpful to get a general idea of what actually takes place with the professional scientific community. Hopefully you're already familiar with the scientific method. Take what knowledge you know, form a prediction, what we call a hypothesis, which is fundamentally an if-then statement. If this happens, then this will occur, assuming what I know is true, and then form an experiment to see if it does occur. Now, the experiment has to be able to disprove your hypothesis, has to be able to say, no, this is not the case. The example I like to give is if your hypothesis is that there are invisible, undetectable ninjas, well, how are you going to know that you didn't find any ninjas because there are no ninjas versus you just couldn't find the ninjas because they're just that good? It's not a hypothesis that you can ask scientifically. Of course, that's kind of an absurd hypothesis, at least hopefully. But instead, we do have a lot of questions that, in general, the scientific method is not going to be able to address. Things like, what is virtuous? What is the good life? These are not unimportant questions. These are absolutely critical, some of the most important questions in the world, but science is simply the wrong tool for that particular job. But let's say you do have a hypothesis. It is something you can test. You run an experiment. You can either A, show that your hypothesis is wrong. It said if this, then that, and something else happened. Or you can support your hypothesis. You can disprove, but you can't actually prove because, yes, what you predicted did happen, but did it really happen because of why you think it did? Maybe. Now, the more times you do an experiment, the more different types of experiments you do, the more you're able to narrow down that, yeah, I think I know what's going on. And your idea of what's going on is known as a theory. But you have never actually proven it, you have simply supported it. Now, it's wrong to say that, hey, it's a theory, it doesn't mean anything. No, there's a very good chance you're right. These have been supported with a fairly strong weight of evidence, but a weight of evidence is not a proof. Now, a couple of quick points. First, the term theory in science does not mean what theory means in English. In English, the English word theory really means what the scientific word hypothesis means. It's a prediction. Whereas in science, a theory is our best understanding of the way the world works that is probably right, at least to the best of our knowledge. Now, I do like to bring in another idea, and that is that of the model. The model is kind of like the theory. It's our understanding of how the world works. It can be a bit simplified sometimes, and in fact, it has to be more simple than the world because the whole world and the universe and everything in it is kind of a complicated mess. But a model allows us to think about what's going on in a way that's, say, a mathematical equation or a graphic or some other conceptual idea, typically a mathematical equation. Now, when you started out, you got all of the knowledge you know. What you really did to form your hypothesis was access back your model of understanding. You looked at the model that you understood of the world and formed your hypothesis from that. What you gain from your experimentation will then reflect back on your hypothesis. Now, your experiment can be something that is an actual experiment. You do something to something else. It could, however, be observational. There are some experiments that you just can't do, either for ethics reasons or just practical reasons. You can't collide two stars into each other because that's a lot more than we as humans can do. And there are a good many medical experiments, like you can't just give someone cancer. That's evil. But if someone has cancer, you can see if a drug makes it better for them. That's what we call an observational experiment. Now, once you've done those experiments, then that leaves a couple of interesting options. You have now improved the model, and if you keep it to yourself, it doesn't really help the greater population much. So as scientists, we like to communicate. In fact, that's really the way our jobs are designed. We communicate what we discover. And we've got a couple of different ways of doing that. The dominant way is what's called the primary research paper. We write a paper, it's in a somewhat stylized form, and we publish it. There are journals that will publish these papers. Typically they are peer-reviewed, so the author writes a paper, sends it to the journal then sends it to 3 typically anonymous other researchers in a similar field, so individuals who would know what's going on. They look at the paper, give feedback, say, hey, should it be published right now? More than likely. Here, make a few edits, or maybe, this is terrible, don't publish this thing. This weeds out junk science, at least it's supposed to. Then, ideally, other researchers, after it's been published, will look at your experiments, look at how you said you did them, and they'll try and redo them themselves and confirm that, yes, what you discovered really is true. This costs money, and it's not happening as much as we would like, so there's a bit of an issue there. But, hey, it is a system that usually works. Now, periodically, though, researchers will realize that, hey, a bunch of research has been done, but it's in a whole bunch of articles that are all over the place and really hard to understand unless you read all of them. And, hey, why don't I read all of them and write an article about all of the papers? This is called a secondary article, or what we call a review article. And these can come in a couple of styles. The simplest is a researcher that is knowledgeable in the field, reads a bunch of the papers that he or she thinks are the dominant papers, and writes a summary summarizing all of the papers together. This is what we call a review article. Now, that could be a bit biased, as was the incidence with low-fat diets and heart disease, a case where a predominant medical researcher had researched the literature, and I should say researched the literature because it was actually the Sugar Board, the trade group for sugar growers in the 1960s, giving him papers and saying, hey, why don't you write a paper about all of these? And of course those were cherry-picked to make fat look bad and sugar look good. So there can be a bit of a there can be a bit of a cherry-picking problem. So the next type is what's known as a systematic review. In this case, a series of guidelines are laid out in the paper saying, I'm going to look at every article on this topic published between these dates that meet these criteria. And then the review covers all of those. This way, there's no particular cherry picking. Of course, you could edge those guidelines a little bit, and there are occasionally discussions on should the selection criteria be a little tighter or a little broader, depending on the topic and the group of researchers. A third variant of the review paper is what's known as the meta-review. In this case, not only are we looking at all the papers published within a certain timeline that meet specific criteria, we're actually taking their research and including it into a data set and running statistics over the whole area of research. This is particularly popular for research that is fuzzy. Things where one paper says one thing, the next say the other, and it's really unclear what's going on. This way, we can take a lot of research samples, a lot of studies, pool them together, and get a better idea of what's really going on with these papers. Now, if you want to read these yourself, you definitely can. Many of them are unfortunately behind a paywall, but services like Google Scholar and PubMed can usually give you access to these, although, once again, some are free, some are not. Many that have been funded by the United States or other world governments typically are not behind a paywall or won't be after a few months. However, paywalls definitely are still a thing.